Hi friends, today we're going to be learning about adding tenths and hundredths. As you can see, I have two fractions here that we're adding together, 2 tenths plus 50 hundredths. I have visuals underneath so that we can visualize why we need to change our denominators. Okay, so on the left you see 2 tenths and I have 2 tenth fraction bars. On the right, we have 50 hundredths, and we can use the coloring tool to help us shade in 50 of those. Okay, in that case, we would need to do 5 longs. So 1, 2, 3, 4, and 5. There's 50 hundredths. Versus over to the left, we have 2 tenths. Okay. So the difference between these is the 50 hundredths includes this entire flat, whereas the tenths are just those 2 longs. So before we add these, we cannot combine them the way they are. We actually have to convert the fractions denominator so that we have equivalent denominators. Okay, we're going to use the equivalent fraction rule. Now with this problem, because I have 2 tenths and 50 hundredths, I could change either or fraction. For us, we're going to start with 2 tenths. I'll actually show you both examples. So I'm going to change tenths to hundredths so that I can add it with 50 hundredths. Okay, so we'll start by doing 2 tenths. And I want to multiply it using the equivalent fraction rule, the big 1, so that I have hundredths in my denominator. I know that if I do 10 times 10, I will get 100. So that means my big 1 is going to be 10 tenths. And I multiply across 2 times 10 is 20. 10 times 10 is 100. So my new fraction that is equivalent to 2 tenths is 20 hundredths. Now I have a common denominator and I can add the 50 hundredths to my problem now. And if we add 20 and 50, we get 70, and our denominator hundredths will stay the same. Now another way to look at this is actually keeping the tenths and changing the hundredths to tenths. I will not always be able to do this. I'll show you an example here soon where I won't, and I will only be able to change the tenths. But in this instance, because in the 50 it ends in a 0, I can divide this one so that I can get tenths in the denominator. So we're going to start with 50 100ths. Instead of multiplying this time, I'm actually going to divide, and I know if I use the equivalent fraction rule, or big 1, if I divide 100 by 10, I will get tenths in my denominator. So again, I'm using 10 tenths. And 50 divided by 10 is 5. 100 divided by 10 is 10. So my fraction is 5 tenths. I now have a common denominator with 2 tenths, and I can add these two fractions. 5 plus 2 is 7, and the denominator tenths stays the same. Okay, so we're going to try a new problem. Okay. So now what I'd like to do, and again I will use a visual, I'm going to use a problem where we will not be able to convert the hundredths. We can only convert to tenths. Okay, so if I use 6 tenths and I add that with 27 100ths, again I see that I have tenths and hundredths in my denominator. I cannot add those the way they are. I need to have a common denominator before I can add my fractions. Okay, so I'm going to just visually show you each one. Okay, so we have for this one, hold on, that's a little big. Let me try the smaller size. Okay, much better. All right, we are going to color in 27 100ths. Okay, we will do, let's see, this is 10. 20, and then we count 7. 1, 2, 3, 4, 5, 6, and 7. This is 27 100ths. Now, if I do the 6 tenths, go back to my tools, I would have 6 of these longs, okay? Another way I could do that is actually using the flats, because we know in the flats, again, let me use the smaller one, these have 10 longs in them. There is 10 groups of 10 in these longs, 10 going across and 10 going down, which makes 100 in this block, okay? So if I'm looking to do 6/10, that means I would fill in 6 longs. So we have 1, 2, 3, 4, 5, and 6 longs, okay? I believe we all know what this is also equivalent to, but we're going to use the equivalent fraction rule to help us as well, okay? So to start, I note that I have 27/100ths in my second fraction, and the 27 ends in a number other than 0, so I cannot convert this number. If the numerator in your hundredths fraction does not end in a 0, you cannot convert it. You will have to convert the tenths. So the 27/100ths will be staying the same, and instead we will making 6/10 into hundredths. Again, using the equivalent fraction rule, I know that to get 100ths in my denominator, I will need to multiply the 6/10 by 10/10. 6 times 10 is 60. 10 times 10 is 100. Now I can add, now that I have a common denominator, 27/100ths. And my new fraction, I will get 87/100ths is my new fraction. All right, there's one more thing that I would like to show you, a conversion, so that when you get over the whole, you know what to do, okay? So if I do this fraction, we're going to do 7/10, and we're going to add that with 83/100ths, okay? Again, we note that I have tenths and hundredths, so I will need to convert one of these in order to have a common denominator. Well, I know I can convert 7/10, that's simple, but when I look at 83/100ths, in the numerator I have 83. That ends in a number other than 0, so I will not be able to change the hundredths number. It will need to stay the same. So instead, I'm going to change 7/10 into hundredths. So we're going to start with 7/10, multiplying by our equivalent fraction rule, 10/10, because we know 10 times 10 will give us 100 in our denominator, and 7 times 10 is 70. I now have hundredths in my denominator, and I can add 83/100ths and find my total. My answer will be 153/100ths, and we see that Miss Cater now has an improper fraction. When I have a numerator that is larger than the denominator, it is called an improper fraction. I need to convert this into a mixed number. And one way that I can do that is thinking about decomposing this problem. If I think about 153, I know I can separate, I'm going to write it down here, 153/100ths. I know I can separate that into 100 plus 53, and then my denominator 100 will stay the same. Now that I have this separated, if I think about 100 over 100, I'm going to rewrite this so we have 100 over 100 plus 53 over 100. And I see here that I have 100 over 100. I know that when I have the same numerator and denominator, that is equal to 1 whole. And then I'm going to add that to 53/100ths. So my new answer, or mixed number, is 1 and 53/100ths. We're going to try one final problem. Okay. In this problem, I'm going to allow you to convert either way. So we're going to do 8/10 plus 90/100ths. Again, I note I have different denominators, so we're going to have to combine them. Now this one has two options. If you'd like to pause the video right now and see if you can solve this problem, please do so. All right, so let's check out our options. My first option is I can take the 8/10 and convert that into hundredths. So we'll take 8/10 using our equivalent fraction rule. We will use 10/10 so that I have 100ths in my denominator, and my numerator will be 80. So now I have a common denominator. I can add 80/100ths with 90/100ths, which will give me 170/100ths. Another option, if you'd like to go the other route, would have been to keep your 8/10 the same and instead convert 90/100ths. And the way I could do that one is, instead of multiplying, I'm going to divide by my big 1, 10/10, using the equivalent fraction rule, which would give me 9/10. If I add this to the 8/10, I will get 17/10. Okay, in both instances, we have a larger numerator than denominator, so we are going to need to convert. And in my thinking, I think when I see 17/10, I know that that is equal to 10 plus 7/10. I'm decomposing 17/10 into 10/10 plus 7/10. Again, when I think of what 10/10 is equal to, that is equal to 1 whole and 7/10 left over. All right, friends, you are now going to watch another video by Khan Academy and then try some practice on your own.